Welcome back to another episode of the PLM Green Global Alliance, talking with persons and companies active in the PLM domain about their sustainability activities and offerings. This time it's a special episode because we are here in the context of Design for Sustainability, a work group which has been initiated by Eirk, Rieger and Matthew Sullivan. Matthew unfortunately cannot be with us today due to logistical issues, but we are very happy to have today Elvira Rakova in our call. She also intended to join the Design for Sustainability group, and she has a very interesting background also as the CEO and founder of a company, Direktin. So, first of all, a warm welcome, Elvira, and please tell us something about you. Who is Elvira Rakova, and what is her passion about sustainability?
Thanks, Jos, for your kind introduction, and I'm really happy to be here on this podcast. So let's just dive into what I do. I always say I'm a mechanical engineer. So because I am a mechanical engineer, and I work in the field of the compressed air systems, so meaning that I take care of the utility that is usually the most expensive one of the most expensive one for manufacturing. And I have a background from the academia where I learned a lot of things, how to reduce the energy consumption, until to the factories where I actually learned that sometimes it's impossible to implement those measures that I learned before, until doing myself the audits and creating at the end the solutions to reduce those energy consumption. So I'm a mechanical engineer and very passionate about sustainability and the rational use of energy.
I expect that air is not the only excitement in your sustainability effort. It's also the planet and other parts of it.
Yes, of course. It's animals. It's a lot of personal things. It's a lot of the nature, and in general, how I ended up. So I always thought I was always like narrow-minded. I would say the mechanical engineer. I did my PhD in fluid mechanics in Germany. And I always was looking at the performance of the systems. And then I just realized I was working, my PhD was on the energy consumption, reduction of energy consumption. I always thought it was nice to have, it was a benefit. Before I would take care of them, designing the system perfectly to have the perfect outcome and make them faster, make them cheaper. But then I realized that faster and better and cheaper and more performant if I make the systems for the production, less energy they consume. And this is where I found the way into the sustainability, that sustainability and energy consumption, it's not a burden for the manufacturing production. It's not something nice to have. It's the result of the system that work correctly. And in our systems, for example, that I work with, they simply were never meant to be efficient. So they are reliable, they are robust, they exist for 20, 30 years without even single touch. And then they were never meant to be efficient and consume less energy.
Okay. But then you didn't decide to start working for a company. You started your own company, Direktin. And why did you start this company?
Well, I started the company because I worked for the company before. So I learned a lot during my PhD. I did some projects. I wrote a really nice dissertation, and then I started to work still I'm an ISO expert for International Standardization Organization, where we develop a standard how to design efficiently pneumatic compressed air systems. So all the systems that use air. Maybe just for your listeners, a little bit to dive deep into the compressed air, where it is used.
Yes, please.
Textile manufacturing, to roll, for example, to do this shirt, to create the tissue, you need the compressed air. For this phone, you also need you have a lot of electronics inside, you have the glass inside. Compressed air, it's the veins of the industry. I'm very passionate about this. So if you have hydraulic drives, it's a very big presses where you require really large forces. They have a lot of electric drive application, but in food and beverage, for example, anything for them, blowing the PET, the plastic bottles, cleaning them, cooling systems, having any motions, and the stamping, packaging lines. It is the utility. It is really utility that is generated by the compressor, and many times it might be 50%, like half of the consumption of the industrial electricity consumption of the plant. So it's basically everything where you see the motion and moving. This is what is happening. And I I learned how to design them. I developed my methods. We started to develop in the ISO, and we're still developing the standards. And then when I came, of course, to the industry, I was on the part, I worked for Emerson, and we were developing there the systems for our clients. So basically for food and beverage manufacturing, automotive manufacturing. And of course, you always start like with the design requirement of the client, and I had to do a lot of simulation and analysis and calculations. And then I saw that we were almost never thinking about the energy consumption, and it was always some plus. And for me, I wanted to make it as a central part of this. And this is why I started my own company. So we basically developed the tool ourselves that helps engineers to reduce also the time while they are doing their calculations. But at the same time, the core of this is that the systems, you always can see and trace the energy consumption of those systems. So this is my company's, let's say, it's a little bit existential crisis together with the knowledge that I gained and with the need that the industry had, because exactly the moment I started to do my research, it was a big ESG agenda in Europe already. And I did my PhD in Germany, and the energy consumption and energy intensive industries were very interested in this kind of topics.
I can imagine, and when I hear the story, I have two remarks. First of all, it looks about energy consumption, reducing it, so everyone should be interested, I would say. I mean, it's directly visible. The second point, of course, I think, although it's the manufacturing side, it has to do with the design side, how you initially imagine your products to be manufactured. And I think that's where often we see the disconnect between engineering and manufacturing. Is this what you observe also, or?
Yes, it's absolutely 100% what you say. In compressed air systems, in all our components, 70% of the CO2 emissions, it's inside the design. So it's not only how it is used later, but also how it is produced and how it is chosen. So a lot of systems that we operate, they are oversized. Not a lot, 99.9999999%, they're oversized because everyone has to be secure that the system will run for 15, 20 years with all the loss, leaks, and all the problems. They are oversized, not a factor 2, factor 10. And this brings to a very interesting point that to make the systems energy efficient, we don't need to create a completely new mind-blowing technologies. We just simply need to design them correctly with the components that already we have, with the methods that we already have, and the physics and thermodynamics that built here for centuries.
Okay, and that is probably your interest in the design for sustainability work group, because it starts with the design. How do you reach the design world? I mean, where the focus is, or the benefits are on the manufacturing side. Who are you people to talk to?
For the design, it starts with let's come back again to the manufacturing, to the compressed air system. So they are quite fragmented, and this is the problem. So you have somewhere the machine that, let's say, blows the bottles. In order to arrive these bottles to be blown, there are components that uses this compressed air, right? So that there is, for example, nozzle where this blowing is like happening. There is a press that is used compressed air. In order this compressed air to arrive to this final destination through those components, you have a distribution part. So there are pipes, and there are some manufacturers, for example, if it is cement or petrochemical, they can be kilometers, can be a couple of kilometers. Yeah. So, and then you have of course, if it is food and beverage, it is smaller, but it's still, it's a huge facilities. And then somewhere you have a compressor room, and this in the compressor room, there sits a compressor. And the compressor generates this compressed air, and it generates by plugging the compressor inside the plug and using electrical energy. So in order to use this compressor at the end, you need to correctly design the components at the point of use. The distribution has to be adjusted to the point of use. The compressor has to be adjusted to the point of use. You have every single manufacturer, so it has to be chosen correctly. It means the design of the plant has to be done correctly. The design from the manufacturers, from the single systems has to be done also correctly. and the design of the single components, including the compressor, including motor, and including also other components inside this. So it is not just a single. I don't want to diminish now colleagues from a heat pump industry or from any other industries. It's not just like that you install something, you plug in, and it has a more efficient motor, more efficient system inside, and now it uses less energy.
Right.
It's a highly fragmented system with hundreds of suppliers that have that at the end it is used for one single or for few applications in the facility. So meaning when we go into the design, the main problem that I see, and again in our systems, is the fragmentation of this. It's not the design per se of a single component. As I said, it's like a puzzle. If we put correctly the pieces together, they will consume less. And for us, a big problem, it is fragmentation of the suppliers. So people that produce compressors, they mostly don't talk with the people that produce the pneumatic cylinder that uses, or nozzle that is uses. So, and this is where the fun part begins, because then you have also the distribution part, then you have a poor energy manager in the plant who doesn't understand what is happening, how much my machine consumes, what pipe I need to put here, how much the compressor is consumed, but also inside the entire consumption, according to the also eco design, we have also the footprints and consumption of those components to be produced. It's extremely fragmented thing, and I think that what we do, so we're creating the platform where we have the tool for design, but at the same time, it is a tool also for suppliers, that they can provide a digital passport of their components. You can put all together them and see the performance of the system. The final, how much it consumes, but also what are the type of components there inside to calculate the fall, let's say. Because in our industry, it's extremely hard to understand who owns the emission. Is it the producer of the cylinder, of the nozzle? Or it is producer of the machine who bought this nozzle to put on the machine? Or it is the end user who at the end uses this nozzle, this bottle.
Yes, I remember this was the challenge with the scope 3 emissions definition, how to measure them and quantify them. That was the big puzzle, as you mentioned it.
It is, and for us, the puzzle is also, and I'm sorry if I go too much maybe into some specific details, but just for me, it's a very interesting and fun part. Whenever you buy this component, imagine like usually when you buy electric components, you have the standard current, so you know how much it's going to consume, or you have the catalog of the motor, so you know how much it's going to consume depending on the speed, for example, right? But here, you don't know how much it's going to consume depending on the pressure level. So the manufacturer, for example, as the producer, when I worked in Emerson, we were producing cylinders, I know how much is, of course I can't calculate, but it all depends on the operational data of the end user. And this is, of course, a very, very tricky part. So we still don't know who actually owns this emission. So it's still not. It's still a discussion in our world who owns it.
Okay, Eirk.
Yeah, so basically, Elvira, I'm listening to you and I'm more and more impressed. Basically, it's a perfect example that you have to consider the entire product life cycle. You really need to start to consider sustainability early in the design phases, and you need to have this comprehensive look. And for me, as a traditional engineer, of course, I never thought, so this type of machines, no one took care about energy consumption. So why? So how do you see the adoption or the awareness of the industry in this area already right now? So is there some interest, or I would assume there's a lot of big way in front of us to make people aware about this comprehensive view, that you need to consider this already in the early phase of design. And what is your view and your experience with industry?
My experience with industry is very different. So I'm a really big fan of my industry in general, as you maybe can see. But motivations are completely different. Again, when we look, I always try to put the energy efficiency as the business case. I want to make energy efficiency profitable because it is a profitable business case. So whenever I approach, and my problem is that I have many clients. I can work with the suppliers of components, suppliers of machine, as well as the facility managers. So it's and facilities, and to see who has the direct benefits and what drives them. Of course, it is an end user. Of course, it is a facility that uses the compressed air, and they have a huge bills nowadays. The problem in the past was, and it was 50 years ago or 60 years ago, and there is a really good study done by Rieger and Blonstein. I actually have it here. Yeah, so I have here the compressed air in European Union. So the book that was my book I started my research with. Basically, people were talking about the leak detection, right? Back then. And in general, a lot of facilities even didn't know that they pay money for compressed air because you don't get the bill because compressor works from the electric plug and you get an electricity bill, right? And now, of course, awareness is coming and it's really decades of years. So people started to pay attention. There is compressed air actually cost money. And then thanks to different auditors, campaigns, people start to say, there are also leaks and we need to take care of the leaks. But now I also notice, and I also think thanks to my popularization also of this topic, then we see that there is a lot of compressor suppliers. They did a really great job, thanks also to the new motor standards, some years ago, new motor standards. So they put more efficient motors. So the compressor started consume less and produce more. And now the final end of use, and this is what is my topic, is the demand side, as we call it, where it is finally used. End users started to rethink, maybe it is actually not used in the correct way. And it is not used in the correct way. And the problem is here, not the problem, but the challenge that I always want to address, it's to the builders of the production lines. They sell their machines and they don't use the machines, so it means that they don't pay for the energy, right? And in our systems, it's called fluid power systems. We don't have the classes like A+. It's not like the dishwasher that you can see. Is it green or red? So you buy a machine, and what is now according to the standard, not even according to the standard, everything that you have now in the technical documentation, you need this level of pressure. That's it. Can you reduce this level of pressure because the bill is high? Not. It's still so. Machine builders, they're a little bit behind, but end users are driving them, and I can see that. So we have some corporate clients that we did the analysis for them of the production lines, and they actually saw that there is a big potential of reducing. So they started to start with machine builders. So there is still policy is missing there. So I would say, and this is extremely, I think it's, in my opinion, it's extremely important because they're obliged to say how much electricity it has to consume, but how much compressed air it has to consume, they're not obliged to. So, but I see also a lot of machine builders are thinking more into the reduction of the energy consumption of their machines, aligned with the ESG goals, of course.
Okay, yeah, what I hear, it's a very fragmented world, and
extremely.
We see the obvious benefits, and the first thing I would expect, where is the platform that is bringing those people together around standards and ways of working? And this is typically something I would say Europe in the Green Deal would do. Is there any traction on this topic in Europe? Do you see it happening?
I had actually a very good experience of presenting this topic in the Swedish Parliament a few years ago, and as well as in the platform that calls EU4S. So it's a European platform for parliamentarians in general, like to speak about this systems. And again, I come from fluid power world. I have also a lot of colleagues working on the hydraulics, that is more popular topic. We have some movements in the ISO standardization on that, and we have some awareness. But I see that with the Green Deal and with those kind of things, it's not, it's very complex. It's not an immediate thing. It's not just replacing one motor by another motor. It's not getting more efficient heat pump. It's a completely supply chain. And I believe, and in my personal opinion, that it has to be the business case. So that suppliers need to see they want to sell more efficient components, more efficient system. The system has to be designed more efficient for the machine builders that then bring it to it has to be more transparent. Yes.
Do you think that things like the digital product passport, which should make this data a little bit more visible, would help, or is it not big enough?
Definitely, definitely. It's actually, well, I don't want to brag about our platform, our solution, but just like what we envisioned. And again, we're still in the startup phase, although I've been in the industry for 13 years. It's basically, I told you, so the supply chain looks like that. You have a supplier of component, then the machine builder, and then the industrial plant. And we have a digital passports. So it is web platform and desktop tool for the design. So there is digital passport of each component that then you can simulate and create the machine. And then this machine you can put digitally in the production line and see how the performance will change. For example, if you reduce the pressure, if you change some components, if you buy a new one. So it's basically like a marketplace for the solutions attached to the tools. But what is more important is, of course, that the experts also has to be around, because it has to be auditors, contractors, energy managers, the project management tools in general. It's a bit lacking now to get into this, and this is what we're trying to tackle, to create this industrial platform where nowadays you can download digital passports, simulate, and then ask for the offer, connect to the suppliers. Now we're working attracting auditors to the platform, also other stakeholders. So kind of to create one place where you can go and simulate and analyze your system. But in general, it's a very, very big challenge, I would say. Because as you said, it's fragmented. What fragmented is the word of the year for me. So.
Okay, Eirk.
Yeah, so basically just listening to you, and we can state basically we have these islands of different activities, disciplines right now. And I'm looking forward to design for sustainability. And it seems to me that the path forward is to combine it. So there are trends like system engineering, digital traceability in conjunction with what you are just telling us are the perfect example for moving forward design for sustainability in the future. So they are basically combining these trends from air pressure and same time with current trends like system engineering. We have a perfect way and approaches to move forward in this way. So I'm very much looking forward in this direction.
Yeah, me too. I'm also learning. I feel like I'm a little bit in my compressed air bubble, so I'm learning new things, but I need to integrate more best practices.
And bring those words together is perfect. That's what I think.
Yeah. So let's bring the compressed air back to also the PLM world. I think if you look in the PLM world, most of the PLM vendors are now actively selling LCA tools, where you can do life cycle assessments, connecting to databases like EcoInvent, to at least to have some impression or analysis of the product. Are you also active in touch with PLM vendors on connecting your tools to their solution portfolio, or are you still in the startup phase standalone?
Frankly speaking, we're still in the startup phase standalone. We're going a bit in another direction, and it's a completely different topic on the connecting to the financing, those projects to the retrofit. But the PLM, I think it's extremely important to connect these processes, because it brings this traceability. And this is why we'll already have the information in the digital passports. And what we started to develop is to align it with the eco design, because compressed air systems are used for a lot of like mechanical parts manufacturing. So we were using the eco design to analyze and to gather those points and to have the traceability. But I think it's an extremely, really good point to discover for us this world and to connect it to this PLM vendors. I'm sure that there is some synergy, yes. We're not active there yet, as the short answer, but
because thinking loud, the big three, PTC, Siemens, Dassault, they're all talking about digital twins, about data-driven analysis of both product design and products in operation. So, and there we already agreed in the PLM Alliance, it cannot be done by a single vendor. It must be a federated environment of connected information.
It is. I think it is also a little bit different now what we do from. So usually the digital twin, it's something that is connected to sensors. So what it is. In our case, it is only the model itself. So for example, Siemens, they also have the system for the modeling. So our next milestone is that we are connecting it also to the sensors to have also the information. But again, it has to be like unified systems, because we have so many suppliers in our fragmented systems that no one of them actually can calculate the entire system. So not a
Yeah.
compressor supplier or not the vendor of the machines. They cannot grasp the whole manufacturing, and this is of course a very interesting point.
Exactly. And what I learned from the life cycle assessments, companies often in the design phase focus on the parts that have the biggest impact. Would you consider compressed air in the manufacturing part as also one of those parts to consider as major impact? Can you say something about the benefits?
Yes, so there are beyond the huge consumption, it can be up to half of the entire consumption of the plant, meaning that it's 50% of the CO2 emission inside the product, the final product. The yogurt that we eat in the morning had the 50% of energy probably was used for the compressed air. So this is from the use
Wow.
cases, and so that I have. Yeah, the table, the food, the manufacturing of the furniture, and so on. And beyond, of course, that compressed air is the center of my life. No, I'm joking, but there are also multiple benefits from this. And we did a study on the multiple benefits, how actually reducing the compressed air consumption can impact the multiple benefits. First of all, it is a safety for the operators, and this is extremely important. Many injuries are happening because of the not correct use of compressed air. Eye injuries, hearing loss, it's very loud production. So, and it has to be also taken care that the sound level also like lower. So downtime of the production of the machines, it has also huge impact. Of course, all the possible cost, but there are beyond the environmental and the cost benefits. There is a huge thing also on the safety and how much then the CO2 is contained, the carbon footprint of the product that is affected by compressed air.
Okay, I think you gave us a great new insight in design for sustainability that we didn't have yet before. The next question is, what's next? What do you expect from us, from people in design for sustainability work groups to focus on and to discuss with you? What do you think is next also in your compressed air bubble?
In my compressed air bubble, I think it's extremely important to understand how our approach can be connected to the also PLM tools that exist, and how our approach can be beneficial for things that already exist, because we gather so much information, and it is a huge industry with so many experts that we're also gathering inside our platform to go into the details. And for the design, I think it's extremely important also to understand the different methods, how the design review methods help design better system. And I would like also, because I focus mostly on the end point of views, but it would be also interesting to go into the deeper details, for example, for the system design as well as the single component design, and to understand how it also can be all connected together to calculate the final impact rather than when it is already used.
Exactly, that's one of the PLM rules, that every stage in the design phases is a factor 10 more expensive to change, and once you reach production, it's very expensive to have still changes. I was also thinking, you're providing software, but there are many tools, but if you are not skilled, the tools are also useless. Where is the knowledge coming from? Are you also providing consultancy? Are experts in the field that know how to make those calculations?
Yes, we provide the consultancy. So we provide engineering services. Our tool, I call it something between the simulation tools and the Excel tables. So because it's really hard to make mistakes there, it will calculate anyways. So people that already work in the field, they can calculate those kind of things. And we also work through our partners, through the auditors and through the suppliers, because we have a marketplace of the components. So our partners use also tool for their clients, and also the auditors, they use it in order to enhance also their reports. Yes, but we do also our engineering. So I also go into the facilities, the industrial manufacturing, do audits also myself.
Okay, and then when there are challenges, there is AI. We haven't spoken about AI yet, so is there anything in the context of AI that you see is going to improve this process
I think
integrating
AI will
the
change
knowledge?
the world. I think it will change the world. And honestly, from the both professional and personal planes, I'm both scared and excited at the same time. Like very personal thoughts apart. It's very, for me, it's very interesting topic because I see there are so many opportunities in the engineering. So for the ways that how we do the rapid prototyping of different applications, for example, the tools that we create for auditors, we use a lot of the AI, but of course you need to have knowledge for what you're using it.
Exactly.
Because just creating some AI agents, really ask AI agent about the calculation of compressed air at ChatGPT, it will tell you all wrong equations only for hydraulic non-compressible fluids. It's really funny. And I see some people start to post it. It is not correct. It's completely wrong. So claiming that AI will understand the data is a weird. Funny story. So we have I went to the facility, that aluminum plant, and they had the measurement, and they said that, we gave this measurement to the colleagues that have an AI tool that analyzed the energy consumption of compressed air. And we have here a very weird peak of from 4 to 5 a.m. in the morning. So it's some anomaly here, and algorithm said it's an anomaly. It's really weird. So for this peak, you need probably to have a bigger compressor, bigger reservoir means more consumption. So when I went through the facility, and very, very important and big topic for us, it's not tools, but it's actually talking to every single operator, asking how he uses compressed air, if he's happy with this application, does he have any complaints, in order to help him. At the end, if you propose different solutions, but no one, they will not integrate it, the work doesn't make sense. It's a lot of the behavioral change too. So I come to the operator Giovanni, and then we start to talk, and then he has like this big machine for the aluminum foils. And then and the facility it's a little bit like half outside, half inside. So it's this big aluminum, like they redo the waste, they treat the waste, aluminum waste. So, and then he's like, I talk with him, then we have a coffee with him, and then he's like, yeah, the life is so hard. I wake up like at 4 a.m. And I come to the facility, and it's very foggy. So I cut for me the tube, the open tube of compressed air, and I remove fog for 1 hour with this tube.
Okay.
And this is cost about 1,000, 2,000 euros per week, this open blowing. So, or even more, I think it was maybe 15, something like that. It's a crazy price because it's a huge tube, and you have a compressor 2 kilometers from there that actually works for this tube. So we gave Giovanni a ventilator for 30 euros. And you don't, and this peak, the anomaly that AI analyzed, is removed. So this is what is extremely important. So there is not enough, at least in our field, trained algorithms for that. And the human factor, and that the system can be used not in an engineering way, it's also not considered yet. And this is why I think it's extremely important to remember. But so many ways to facilitate the projects and processes, this is a huge change. So I can see that it is such an amazing work. It's a huge change. All the project management tools, web tools that we're developing, we're using AI tools from 6 months development team. It reduces 2 days in the rapid prototyping. We give clients to test it and to see it. And from the monitoring part in the facilities, it can, we also develop in our algorithms. I also work as a researcher at university here as postdoc in Italy, and we develop algorithms for the fault detection, early fault detection. And usually you need a lot of sensors. That is not profitable to install so many sensors for this fault detection. With the AI algorithms, it's actually possible to identify and predict behaviors based, of course, on the physics. So we use the algorithms that the supervised learning based on the physical behavior. We already can predict it without using additional sensors that are very expensive. But I a little bit worried about the extreme energy consumption that is required for the AI. And I think we need to combine energy efficiency together with AI, because in our cases, the energy consumption reduction, usually projects that we achieve, it's about 30%. 30% reduction without without creating some new hydrogen plane or like some crazy solution, that with the ROI under 12 months. So, and it's not even the energy efficiency anymore. It's not even the together, especially with AI and how does data centers, the gigantic consumption that is required for those algorithms in the future, and it's growing, without energy efficiency and the correct design of the system for sustainability. I think we don't have a really nice future. So we have to combine it. If we want to use AI, we need to be more conscious about the design.
Exactly. I think we share this worry about energy consumptions, and it made me think about also electric vehicles. Now they are there, they are more efficient, but now people start to buy SUVs because, and then, I mean, the energy reduction could be so much more. We're reaching the end. Eirk, do you have a final point or question?
Yes, so from my final perspective, basically, I'm really impressed and really surprised. It seems to me that combining two bubbles, and what I learned along our discussion right now, that we're also in a bubble from the mechanical engineering design, and combining both bubbles gives a lot more potential. So it sounds like a bit like 1 to 1 = 3 equation. And I look very much forward to work together to leverage this new potential.
I think so too. Elvira, thank you very much for this exciting topic and bringing it in the Design for Sustainability workshop. And we are looking forward, as Eirk says, to combine the bubbles in an even bigger, more efficient energy bubble.
Create one big bubble. I agree. Thanks a lot. Thanks, Eirk. Thank you, Joseph.
Thank you.
It was really
Thank
a lot
you.
of fun.
Thanks. Bye.
Thank you. Bye.